First lecture on networking, that's Computer Network 2, CS452, is basically on wireless LAN. If you look into lesson plan, the topic is wireless LAN, where we have two topics to be covered. First is wireless medium access control protocols and IEEE 802.11. Now, let's start with first what is wireless access control protocol. Wireless medium access control protocol is basically, if you look into 7 layers of OSI model, in second layer it comes. Actually, data link layer has two sublayer. One is called medium access control sublayer and LLC sublayer. And medium access control sublayer we have something called MAC, medium access control protocols. So why we need MAC? Basically, each and every device need to be identified, and that is the reason we should have IEEE 802.x protocol, MAC protocols. And in MAC there are two types of standards. One is called one is wireless wired and wireless standard. Now, wireless standard, when we look into wireless standard, it has a wireless medium. So what is wireless medium? Wireless medium is all about open, shared and broadcast medium, where it is using the medium, that's air medium, sending signals. Now if you look into the architecture of IEEE 802.11, which is nothing but IEEE 802.11 is standard. Now if you look into IEEE 802.11 standard, it has in architecture, it has two things. One is called BSS and one is called ESS. Now what is BSS? The full form of BSS is basic service set and ESS is extended service set. When we talk about wireless access point, it has two things. One is basic service set and one is extended service set. And when we talk about medium access control protocol, we always talk about this. So ideally, MAC protocol has limited delay, high throughput, fairness, stability, scalability. These are the points what we are going to discuss later on. What the discussion, we will touch upon this. So basically, when we talk about carrier sense multiple access, CSMA, CSMA has CSMA CA and CSMA CD. When we talk about CSMA CD, okay, there is a basic ideology behind talking about carrier sense multiple access, that every node need to sense the carrier before transmitting. So every node know that whether the carrier is busy or carrier is free, because there is a persistence algorithm which decide, and if the carrier is not clear, then it will be, there will be delay, and accordingly it will detect the collision. Collision detection is basically detect the collision and then it will dispatch. Now there are issues in wireless that due to hidden exposed terminal problem, there are certain issues. Now we will discuss about that. Now before that, let me tell you what is BSS and ESS, basic service set and extended service set. BSS and ESS is how access points are basically giving connections to, in an infrastructure network, giving connections to different okay, end users or stations, I will rather say stations. So it basically create an ad hoc network. When we talk about mobile ad hoc network, MANET and all, we will be knowing this in details. But when we talk about ad hoc network, it is basically creating the infrastructure. That means this is wireless access point and this is connected to different stations. Now when you have such stations, now due to the architecture there are certain issues. So there can be hidden station, there can be exposed terminal. So these are the issues of hidden station and exposed terminal, because there are basically basic service set where one access point is connected to all devices directly, and when we have multiple access point in distributed systems, there are hidden and exposed terminal problems much more into details. Now basically we call it as channel access problem. Now for example, we have A, we have B, and we have C. Now if A is exposed to B, there are different issues like exposed station and hidden station problem, but uh, basically when multiple nodes share a single channel, this kind of issues are there. Okay. Now we will be talking about MAC sublayer in details later on, but basically when we have wireless devices, there is a pairing. Now when we have a pairing, now pairwise communication has different issues. Now what MAC protocol is suggesting a scheme how to scheduling all those things and how to create such things. Now basically when we have wireless MAC channel, we have issues like half duplex operation, time varying channel, burst channel error, and the more important thing about this is hidden terminal and exposed terminal problems. And we will talk about capture effect. Now, when we talk about MAC and MACA, okay, this is basically came from medium access control protocols collision avoidance scheme. Now, when we have CSMA, in CSMA, CA, if we take these two, we get MACA, and when we have MACA for wireless, it is called MACA. Now in 1992, Kern's algorithm already you all have studied. The same researcher find out this in 1992, the protocol MACA. Now wireless MAC protocols are actually non-trivials, and now later on a research paper in 1994 gave details about MACA. Now this all are IEEE 802.11. Now standard was ratified in the year 1999, and we use the standard which came in the year 1999. Sorry. Now this is different devices. Let's talk about how IEEE 802.11 works. So basically in wireless LAN we have something called different types of transmission. Now when there are different types of transition, we have BSS, ESS, mobility. Now for example, this is a sender S, and this sender S is sending some data to D. Now there are two things. One is called request to send, and there is something called clear to send. When S is trying to send some data to D, it will first send a request. So this is before sending the data. This is initially there is a request for sending the data, and there is a acknowledgement how it will actually say that D will actually give a clearance to S that S can now send the data to D. Now all other remaining stations will be silent, and after that S can send the data to D. So first RTS, then CTS, then it can send the data. Now after sending data, there will be acknowledgement process, and finally if you look into the transmission, first this function will tell okay that don't look into all those things. If you simplify, first there is a request, then there is a clear to send, then there is a data transmission. So sender to receiver RTS, receiver to sender CTS, clear to send, sender to receiver data, and receiver to sender acknowledgement. And this is the algorithm or steps how this happens. Okay. Now there are a lot of other issues. Let's not go into this because we will discuss this again. Now when we talk about hidden terminal problem, how hidden terminal problem has been a big issue, let's understand. So first we will understand what is hidden terminal problem. Before that, let me just give you a basic idea, okay, how MAC sublayer works. When we talk about MAC sublayer, MAC sublayer is basically, this is my physical layer and this is my MAC sublayer and this is my LLC sublayer. This is called data link layer. If we talk about physical layer, this is data link layer. Now data link layer in LLC, we have all those standards, IEEE 802.11 standard. When we look into MAC, there are two things. One is called PCF and one is called DCF. Okay. Now let's understand what is PCF is. The full form of PCF is point coordination function. The full form of PCF is called point coordination function. Let me write it down. Point coordination function. And DCF is basically distributed coordination function. Now when we talk about DCF, when we talk about IEEE 802.11 in MAC sublayer, we have something called DCF. So DCF uses CSMA CA for the access method. So why we cannot have CSMA CD collision detection? There are three reasons. For collision detection, a station must be able to send data and receive collision signal at the same time, which is not possible in case of wireless. And collision may not be detected in such cases because of two things. One is hidden station problem and exposed station problem, and that is the reason DCF, this distributed coordination function, okay, is basically pointing towards CSMA-CA, and we get a protocol which is called MACA, and we have something called point coordination function PCF to find out all those things. Now when we talk about this, let's understand this in details, how it works, this CTS and RTS. Now for example, this is sender and this is receiver. Now when we have sender and receiver, first sender is sending a data to the receiver. Before that, sender has to wait because this is using CSMA CA, collision avoidance, to collision avoidance. So for that we have something called MACA, and we call it as MACA because when it is having wireless MACA. Now this time, at time t1, it decides to send some packet or send some data, send some signal to receiver. So this receiver, now S is sending some signal at the time t2 to receiver, and this is RTS. So before that, there is a difference between t2 and t1. Now this is called DIFS. So what is DIFS? DIFS is basically to find whether the channel is idle or not in case of MACA. Now when a station at time t1, when this particular S decide that it will send some packet to receiver R, it will not send immediately. It will wait for some time. So it will wait for the period when it find out that this station is rather idle or free to receive some signal from sender. So this will be, there is a backoff time which is called DIFS. This backoff time is called DIFS, which decides that when to send a request. So this is called distributed interframe space. So this distributed interframe space is to define that when to send the signal. Now after that, it will not send the clearance immediately. So CTS will also wait for some time. There is a back off time. This is called SIFS. So this SIFS is called short interframe space, to find out that whether there is a clearance which need to be sent to receiver or not. So after that, this SIFS, again there will be another SIFS at this sender before sending the data. So this SIFS basically decide that before dispatching any acknowledgement or data or clearance, that whether the station will be really able to receive or send or not. So this basically, there is the same equal amount of time is there, SIFS is calculated to find out when to send the data. So there is something called NAV, network allocation vector. What is NAV? Network allocation vector. So this network allocation vector is basically calculating CA, means collision avoidance time. So network allocation vector, when a station is sending a RTS frame, it includes the duration of the time it is needed to occupy the channel. The station that affects by the transmitter to create that particular timer is called network allocation vector to check the idleness. So basically this network allocation vector is to calculate that factor, and after that there are certain issues we will talk about during handshaking, how to do this. So basically now let's decide upon how this works. So node B can communicate with A and B directly. So D cannot communicate. Now since D cannot communicate, D is not exposed to A. Even C is not exposed to A. Now AC cannot hear each other. Now D and C can hear each other. B and C can hear each other. A and B can hear each other. So when A transmits to B, C cannot detect the transmission using carrier sense mechanism. And if C transmits to D, there is a collision can occur. So hidden station problem, let's understand. Now how to increase the carrier sense range? Now for example, C is transmitting some data to D, D is sending CTS to E, F is asking for E. So now how to avoid collision in case of hidden terminal problem? Now E has to defer sensing the carrier, which will lead to a no collision. So for example, if there is such issues, E does not hear C. Now if C is trying to send some data to E, now this data will come to D, but there is carrier sensing issues. So if CTS doesn't come to C, there are issues. So that is called hidden terminal problem. Now there are one more issue for exposed terminal problem. Now what is hidden terminal problem and what is exposed terminal problem, we need to understand. Hidden terminal problem was basically what? Hidden terminal problem, every station can actually hear the signal which is transmitting from its neighbor, but the other stations cannot hear the signal. Now what is the solution to the such hidden station problem? So basically what is hidden station problem is basically in clear to send in CSMSCA there is a possibility of collision. Now it always cannot send a clear to send because E does not know C and C does not know E, and that is the basic reason of hidden station problem. Now the solution to hidden station problem is use of handshaking frame in case of RTS CTS. Now we have 3-way, 4-way, 5-way handshaking, which we'll discuss later. Now using that we can do, or we can actually handle this problem. If you come back to this particular diagram, let's create a diagram to find out how to give a solution to the problem. Now, for example, there is a station B, there is a station A, there is a station C. Now, assume the station B is sending data to station A. In the middle of the transmission, station C is also sending the data to station A. However, station C is not in the range of B and station B is not in the range of C. So therefore C may think that station B is free and B may think that station C is free. Now in such cases collision can occur due to hidden station problem, because B is not exposed to C and C is not exposed to B. The solution is use of handshaking frame of RTS and CTS. Now first B will send a RTS to A. Now RTS message from B will reach A, but however B and C is within the range of A. Now A will decide how to help B and C together. Now in such cases A will manage. Now A will do the clearance. Now for example, at this juncture A know that whether B or C are free, B or C free or not. Now simultaneously for such transaction A will send a CTS to B and C, and in such way at time t prime both B and C know with the help of A that they both can transmit data. Now they can transmit data via A, since A has sent a clearance to both B and C for the transmission of B to C. And this is what a hidden station solution to a hidden station problem. Now next is exposed station problem. Now consider a situation where stations are exposed to each other. Now here in this case node C can communicate with B and D. Now C can communicate with B and D. Node B can communicate with A and C. But node A cannot hear C and D, and node D cannot hear A and B. When C transmit to D, B detect the transmission using carrier sense mechanism and postpone the transmission, even though such transmission will not cause the collision. So this is because of such older algorithm what I have actually discussed with you is actually a problem for an exposed terminal problem. There is a delay in exposed terminal problem. So how to overcome such problem? So let's find out how to overcome such problem. Let's give a new diagram. Now for example, B is a station, A is a station, C is a station, D is a station. Now in such cases the handshaking message RTS and CTS has to be sent. Now for example, there will be a simultaneous process. Now A can simultaneously send RTS to B and send RTS to C for different transmission. Now reply, this can send a CTS. Now if this send a CTS, now there is a data transmission in A to B. But if this CTS B is sending for a transmission of C, there this CTS can be extended to C also. Now this CTS A is sending it to P. Now if A is sending it to C, in between if C is also sending it clear CTS, or if C is also giving a signal, now this CTS can go till here. Now these data, now there can be another transmission in this section for the communication in between B and C, which A can help. But ideally, if you look into such situation, there should be a delay. But since A is communicating with B in a separate channel and A is communicating with C in a separate channel, there is a possibility there should not be any collision. Now let's take another situation. If the station C now hears RTS from A. Now station C, after some time, can they send the RTS and CTS both to A and D. Now it happens due to both exposed station problem and hidden station problem. Now if you look into the solution of exposed station problem, if this continues, there is a possibility of collision. Now at this juncture, for example, both send RTS and try to communicate. Now if there is some data which is trying to go from C to D and simultaneously there is some CTS comes from D to C, due to solution of exposed station problem, there is a possibility of collision. Now this is what one of the problem. Now we can say that carrier sensing making the situation worse. So handshaking is one of the solution, but during that this RTS and CTS, this also need to be pipelined or streamlined when handshaking takes place. So 2-way and 3-way handshaking is not a solution to this. Now let's find out. In a nutshell, we can say that 802.11 handshaking does not solve HTTP completely, but it elevates the problem. It only elevates the problem, and it recommends a larger zone. But the larger zone has some issues. Now that is the reason we still have wireless MAC research. Still Macau research is still going on, and we are still trying to find out a better solution for this. Now if you summarize, let's have a text on 802.11. So we have already understood that rule of RTS and CTS. We have already understood that acknowledgement is necessary in case of MACA. MACA said no acknowledgement, but TCP connection said that there should be some acknowledgement. That is the reason we have RTS, then CTS, then data, and finally there is some sort of acknowledgement at this. Okay. Carrier sensing should not replace entire RTS and CTS, but it should help RTS CTS process in a better way due to hidden and exposed station problem. Now we don't have such capture effect immediately, but there is a capture effect. In our syllabus we don't have capture effect, but you can find out capture effect solution if you read into this. So if we look into the 802.11 overview, so we can have 802.2 and 802.11 at LLC, but we have medium access control protocol at data link layer. So we have 802.11a, b, g and mixed mode communication, which we'll talk later when we discuss wireless in details. In medium access control, we have seen carrier sense, multiple access, collision avoidance schemes. So that is the reason we have seen MACA for we have seen MACA and MACA for wireless. We will give you more handouts on this. Now scopes and now if you see the sublayers and scopes in MAC and physical, we have MAC layer management and physical layer management and certain topics to be studied. Okay. Now we will talk about single hop and multi hop issues later on. Now if you see, we have already discussed BSS and ESS. These are the architecture. When we talk about infrastructure mode, this is already there. We have already spoke you about this. Now when we talk about physical technology, there are two types of radio based spectrum. One is called spread spectrum and diffused infrared communication. We have FHSS and we have DSSS. These are the different frequency bandwidth for IEEE 802.11 spectrum. Now what is FHSS? FHSS is basically frequency hopping spread spectrum. This method which we will discuss later, it uses FHSS uses 2.4 gigahertz ISM band for communication. This is a communication system. And DSSS, which is called direct sequence spread spectrum, which is basically one of the this is basically data link layer methodology. Now DSSS is basically using again the same 2.4 gigahertz channel ISM band. So these two are the two different mechanisms. So DSSS is using diffused infrared communication system, and this is using FHSS is using no sorry if you look into the spread spectrum, FHSS and DSS both are using spectrum, and this is using frequency hopping and this is using direct sequencing. And if you look into diffused infrared, there are now spectrum is basically FHSS and DSSS, and if you look into diffuse infrared, this is a different scheme what is using other channel mechanism, but for our study we will be using this. So there are different license required, so there are different standards from Europe and Japan. If you look into this, you can find out this. So this previous semester we have already studied different signal to noise ratio and all. This is same in case of split spectrum. If you look into the calculations, we'll study discussed this mathematical portions in class. So this is FHSS, this is DSSS for communication. So these are the different channels for different channels are used, which we will discuss in the next class later on. So I'm just showing you that different sublayers and protocol which is used. This is not here in our syllabus. So if you look into classification of wireless MAC protocol, there are two types of protocol. One is random access protocol and guaranteed access protocol, which we have discussed in case of wired protocol also, wired channel also. In wireless channel also you have distributed MAC protocol and centralized MAC protocol. So these are the distributed MAC protocol which we have been discussing. Centralized MAC protocol we will discuss later. So this is MACA. So MACA, let's have basic idea of what is MACA. MACA is basically a protocol which uses three-way handshaking. We have already discussed about three-way handshaking in IEEE 802.11 protocol standards. When we discussed about that, we have already discussed these protocols. So basically the MACA is the first protocol for let's discuss how MACA came. MACA is basically CSMA, is a short form of CSMA-CA. MACA is a protocol for collision avoidance. We have already discussed in previous semester what is collision avoidance. So fundamentally this uses different handshaking method when we have such hidden station and exposed station problem. So what is three-way handshaking? Three-way handshaking is basically how we send the data. For example, A, B, C, D, E, these are the different stations. Now A is sending a data. Okay, so this is called request to send. Now in reply B will give a clearance, that is called CTS, clear to send, and finally A will send the data to B. So this is basically three-way handshaking. Now more details in MACA, we can actually say that MACA is a protocol used to identify different time frames of RTS, CTS, DIFF, DIFS and SIFS. So we have already discussed this in details. Now this is hidden station problem, and this is due to this problem there is a possibility of collision. So basically this problem is we can have only a solution, but it's not a full-fledged solution. Now let's see what is hidden station problem. We have already discussed. A is sending a request to B. Now B is giving a clearance to C. Now A is sending a data, and simultaneously C is sending a request Now what happens? The data packet, due to hidden station problem, may not travel properly. Now we have already discussed this in details. Now we have already have exposed station problem, what we have discussed in details. Now this is IEEE 802.11 MAC. So this already we have discussed. Carrier CSMA. Just showing you the slides. These are the slides what we have already discussed. So this is the summary. We will discuss MAC later on. So thank you.